welcome back. I've got an interesting video for you today, and it's especially for those of you that wear contact lenses. Have you ever noticed that when you take the contact lenses case and you open it and you look at the lenses in the fluid, they almost seem to completely disappear? They're very difficult to see. But as soon as you take them out and put them on your fingertip, they show up really well. If ever you've been in that terrible situation where you drop contact lenses into the sink full of water in the bathroom, you'll notice that they completely disappear and you end up chasing them around trying to find them. Well, there's some interesting physics going on there, and it's this I'd like to explain today. So, I've got an interesting demonstration to show you here, and it's why I call the video the disappearing test tube. I've got a beaker of liquid, and inside it I've got a large test tube. But if you look carefully, you'll notice that it seems to stick out the top of the liquid, but there doesn't seem to be any test tube underneath. If I hold it up, you can see the test tube poking out the top, but it seems to completely disappear when it's in the liquid. This is exactly the same process that happens when you put your contact lenses from air, when you can see them reasonably well, to under the contact lens solution. Once they're in the contact lens solution, they seem to completely disappear. I think it's worth me pointing out here that there isn't a sawn-off test tube in here, but in fact there is the full length of a test tube. But when I put it in the liquid, it just seems to completely disappear. So I've got some explaining to do. But before I do that, I'd like to show you one more experiment. So here's another experiment, and one I've been wanting to show you for a very long time. I've got a jar here with some liquid in it and some things floating on the top. But what I'm going to do is I'm going to turn it upside down, and I'd like you to watch what happens to the bottom layer when I actually turn it upside down. So there we go. It was full all the time. Now this really is going to take some explaining. So it's nice to see these experiments from different angles. So I've got a few photographs here of the disappearing test tube, and I can take pictures of it from various angles, so you can see that the test tube appears very clear when we see it outside in the air, and when the glass is in the liquid, it completely disappears. It's very, very hard to see, just like contact lenses in fluid. The same applies with the floating balls. They're not floating at all, of course. They're filling the jar, but when they're in the liquid and under the liquid surface, they appear to completely disappear. But when we remove the liquid and they're in the air, they show up very, very clearly. So, time for an explanation. And we're going to use the physics of refraction to explain this one, something that I've dealt with in a previous video. If you remember, the contact lenses appear easy to see when they're in air and very difficult to see when they're in a liquid. So there's something in common with them and these two experiments. Light, if you remember, is a wave, and when it travels through different densities, it slows down or changes direction. So when the light hits the glass, it changes direction and slows down and makes it easy to see the glass. However, with contact lenses, if they're in a fluid or a liquid, just like the test tube glass is in this fluid or liquid, and the balls here are also in a liquid, if they have the same optical density as the liquid they're in, the light doesn't know, so it just carries on undeviated. It doesn't slow down or change direction. It's for the same reason that you can't see a bit of water in water, as it were, that the light just travels through the water and doesn't slow down or change direction as it's doing so. So, contact lenses in air are a different optical density to air, so the light does slow down and change direction. Contact lenses in a fluid are the same optical density as the fluid, so the light travels without even realising the contact lens is there. I hope you enjoyed that experiment. I'll try and write in the comments how you can do this at home. You probably haven't got test tubes, beakers and a lot of glycerol to play with, but I'll explain where I got these water gel balls from and how to make this experiment, which is really rather nice. And you can ask other people what they think's going on once the gel balls have come up to full size. Hope you enjoyed that video, and I look forward to seeing you again next time.